All right, so number 8 is definitely different, okay? They gave you a shaded region, they gave you a b value, they gave you an a value, and then they give you this function that they're calling, let's say, f of x. They're calling it f of x and f of y. So depending on how you look at that function, whether you're interpreting a vertical length, which is f of x, aka y, or if you're interpreting a horizontal length, okay, which is f of y, otherwise x. All right. So I'm going to be drawing as I go through this. And then, like A, B, C, I'm going to be drawing the vertical and the horizontal distances that I'm talking about right now so that you can see what are the answers to A, B, C, and D. Okay. So let's go ahead and go to the iPad. All right. So the first one, this is how we talk ourselves through these problems. dy is what it's giving us. As far as this tells us these are horizontal slices. Dx tells us that these are vertical slices. Again, down here, dx is the same thing, vertical slices. And finally, dy, those are going to be, again, those horizontal slices. That's how you first start off, okay? The second thing that you should identify is it the disk or the washer method? Okay, is it the disk method, which is just one r value that you have, and it could be dx or dy, it doesn't matter. Or is it going to be the washer method where it's big R squared minus little r squared? Okay, so let's highlight those pieces here. We have like big R squared minus little r squared. We have big R squared minus little r squared. We have, so those are going to be our washer methods. And then over here, we just have one square piece, which is r squared, otherwise our disk method. And here we only have one squared piece, okay? So that's how we identify that this one here is washer, this one's washer, this one's going to be a disk method, and this one is going to be a disk method. That's how we can identify our equations, but also with the dx and dy's are vertical and horizontal slices, if you will. Okay, so let's go ahead and go to A. A is saying a washer method with horizontal slices is from 0 to B. Okay, so if I'm looking at from 0 to B, let me highlight that in, let's say, blue. From 0 to B, I'm talking about from this 0 all the way up to B. Okay, and I'm going to be looking at horizontal slices because these are dy. So whenever I'm going to find a washer method, and this is revolving around either x equals 0 or y equals 0, this specific first one is going to revolve around x is equal to 0. All of this is going to come around like this out of the page and revolve around x is equal to 0. Okay, so with that in mind, I'm going to go ahead and show from the axis of rotation, okay, from the axis of rotation that is, in this case, x equals 0, I'm going to go to the outermost edge of that shaded blue region. Okay, so let me take these off. So now looking at this, I know that I'm touching the x-axis here, and I'm touching x equals a over here. Okay, because this is horizontal, I'm going to rotate my head 90 degrees to where now this is the top. So my top function becomes this line, again, because I've rotated my head 90 degrees, and it's going to be a. That's why you got a squared here, because technically that big R squared is the top function of a, okay? And it's minus the bottom function, which is way over here. It's going to be 0. So a minus 0 is still a. That's why you have a squared. That's what's going on there, okay? So now let's go ahead and go to the other piece, that f of y. So minus little r squared, again, from our axis of revolution, which is x equals 0, aka the y-axis, we're going to create a small little radius that goes from there to the inside function, okay? And this right here is going to be touching it right at this point here and this point here. Okay, so this distance right here is x, otherwise known as f of y. Okay, so f of y or x, however you want to look at it. Okay, so if I rotated my head yet again, where this is the top, then I know that this length, this horizontal length, needs to be written in terms of y. Okay, so that means I have to solve for x and get x alone. Well, this equation, x is not alone. Here, x is alone, so that I can write it in terms of y. So this length is going to be f of y minus 0. Otherwise, where it touches here is f of y minus where it touches here, top minus bottom. So whenever I put that over here, I'll have f of y minus 0, which is the same as f of y squared. Okay, so because it's little r squared. Okay, so that's how you do that one. Now let's move on to b. Okay, so if I was asking myself, what was that rotating about? This right here would have been the y-axis. The way this is written, it's going to be the y-axis is what you're rotating it about. Okay, now let's come over here and look at this one, part B. Okay, so part B is a washer method. So we're going to have a big R squared minus a little r squared. They are vertical slices because we had dx, so we have these kind of vertical slices, and we're going to rotate them about something. You know, in this case, what you're used to now, as far as like just intuition-wise, chances are that this blue region is going to rotate about the x-axis. And if it rotated about the x-axis, let's go ahead and do that, then I'm going to have from 0 all the way to a, which these check out, are going to be my interval, because these are going to be these vertical slices. And if I created one from the axis of revolution out to the outermost edge of that blue shaded region, then I have a top minus the bottom. I don't have to rotate my head whenever it's dx. I don't. I'm just looking at it where this is the top. So the top function has to be in terms of x, okay? Because it's dx right here, I need to have these functions in terms of x, which I do, okay? So it'll be, this one's asking b squared is the top one. So this one's a little bit different because that's not what's going on here, okay? I don't have my top function as being b squared. It doesn't show that here. My top function, with my assumption that's rotating about the x-axis, my top function would actually be f of x, okay, which is this graph right here. But that's not what I have here, okay? So f of x, it is shown in part C. That's what would be f of x minus my 0, which is the x-axis, and then squared. This one would be the x-axis. So the first one was the y-axis, and that checked out. This one is the one that's the x-axis on part C. Okay, and it is a disk method because you don't have the big pi r squared minus the little pi r squared. Okay, so f of x is my top, 0 is my bottom, which is negligible. You could just write f of x quantity squared. It's from 0 to a, it checks out. Okay, so, oops, I just realized what I did. Let me write that correctly as x-axis. All right, so B is a little bit tricky. Okay, it's not going to be my assumed rotating about the x-axis. So it's going to rotate about something else. Okay, so far let me highlight y-axis, x-axis. Now we're going to find B and D. So if B squared is my big R, that means I have to create something that goes all the way to B. And I will either create it this way, where it goes out that to B from the x-axis, or I will create it from the B, which goes out this way. Okay? So we know that the x-axis is the answer to C, so it has to be this one, with what I've drawn right now. Okay, so this is saying I'm rotating this about, so let me write that over here, about the B axis, or not B axis, y equals B. That's what I'm rotating this one about. Okay, so if I were to create a line, let's go ahead and do that real quick. Let's say we are rotating it about this line right here. We are rotating this blue region about that line right there. So it's going to come out of your page looking like this, going back around, this, going back around. Let me make that a little bit predominant. Okay, that's the rotation that is happening because it's rotating about y equals b. All right, so now with that in mind, let's go ahead and verify that everything checks out by drawing a big R squared minus a little r squared. Okay, so from B, that's our axis of revolution, I'm going to go out to the furthest most function. Okay, these are vertical slices. So let me go ahead and put endpoints on this green line. And if I were looking at this with vertical slices, this is still the top. I don't have to rotate my head. My top function is B. My bottom function is down here as 0, and it's top minus bottom squared, which the B squared right here checks out. So far, so good. Now, when I go to do my little r, I'm going to go from the axis of revolution. That means I'm going to start at B and then go to the innermost function where it hits. So now, looking at this purple line, my top is going to be B. My bottom is going to be f of x, because again, these are vertical slices, so everything's in terms of x, and that will be my little radius. That's rotating about y is equal to b. So that did check out because that's right here exactly how you see it. Okay, so y is equal to b is the answer for the second one, part B. All right, so now let's go to D, the last one. It's going to be horizontal slices because we have that dy. Okay, so let's imagine horizontal slices, and we're going to rotate about some axis. Before, on part A, we rotated about the y-axis, which is x equals 0. That one worked. So chances are that this one is not going to be that way. But this A is kind of screaming at you of maybe it's A as far as that axis is concerned. Okay, that axis of revolution. So let's assume that it's A. Let's test that out. So x equals A is going to be a vertical line. Okay, let me go ahead and write that over here. X equals A is that vertical rotation. And we're saying, well, maybe it rotates about this axis. Okay, x equals A. And if it does, let's go through the steps to make sure everything checks out. First of all, we do have horizontal slices. Check with the dy. It is a pi r squared. Okay, it is a disk method because this blue region is touching this axis of revolution everywhere with no gaps. Okay, so far so good. 0 to b means from 0, as far as a y value is concerned, all the way up to b, it is still checking out. So now we just have to rotate our head, assuming that this is the top, and see, is this top function minus the bottom function going to work out? Okay, so here we go. Let's go ahead and let's go back to drawing the radius. So again, from the axis of revolution, I'm going to draw the radius out to the furthest outer edge. And I can pick any rectangle, remember, anyone in the interval from 0 to b, and I'm going to stop at the function. Okay, that means this is an input and this is an input, or sorry, endpoint. So when I rotate my head, sure enough, this is now the top. My top function is x equals a. So it would be a minus the bottom function, which is right here, but it has to be in terms of y. So it's going to be minus f of y. So top minus bottom squared, that would be my radius. Again, this is a disk method. and it all checked out. So what axis was the revolution or the area bounded revolving around? This would be the axis x is equal to a. Okay, so that would be the answer for part D. All right, so yes, it's all about identifying horizontal or vertical slices, identifying whether it's going to be a disc or a washer method, and then kind of you can, if you want, assume that it's going to be like the edge of one of the shaded regions or even the X and Y axis as we've been doing on many other problems from before. So that's it on that one.